with two eyes facing forward, therefore a carnivora, or a carnivore. If you just look at the right eye, you will see two lines emanating from the eye. And inside those two lines is called the field of vision. That is what the animal can see when he's looking straight ahead. Similarly, from the left eye, there are two lines, and between those two lines is the field of vision for the left eye. If you notice, they are superimposed, and the area colored green is the superimposed visual fields, and that is called binocular vision. If an animal is just looking at you through the blue, the monocular vision, he can see an object or an animal, he can see the width, and he can see the height. But he has great difficulty in knowing how far away exactly is the animal. But in overlapping fields, binocular vision, he can see, or she can see, how far away that animal is, the depth of field. That's wonderful for a carnivore or predator because he wants to know exactly where his prey is before he makes the final lunge. This is a very different set of visual fields from a herbivore or an impala. The orbits, if you recall, are on the side, therefore the eyes are on the side, and the visual fields have very little overlap, very little binocular vision. So that makes you feel sorry for the impala, but you should not, because there's a reason for that. This visual field can look behind him. All he has to do is rotate his skull a little bit, and he can look completely behind him. Granted, it's monocular vision, but he can tell if a predator is coming at him from behind, which is the way they usually do. This is another very simple scheme of the eye, looking at it from the side. I'm showing you a ray of light, which is called a photon. It's coming through the blue opening, which is the pupil. It's going to the back of the eye, to the green retina. And in these animals, it goes, some of the rays go further. They go to the yellow to gold membrane called the tapetum lucidum. You do not have one. You could not buy one if you wanted one. And it's a wonderful structure. In us, in our existence, in our eye, the photon comes through many, many photons, and they are mostly absorbed by the retina. But some escape and go right through it and are lost. But in this animal, he has this membrane behind, which has a sheet of cells on it. And each of those cells has a crystal in it, which reflects light. So when the light rays escape the retina, they hit these reflective crystals, and the remaining light is reflected back into the retina. Nothing is lost. That, in my mind, is ingenious. That is one of the reasons these animals are so wonderful in predation. Now, the third thing is rods. If you remember, rods and cones are tiny nerve cells. They are the first nerve cell of your vision. Rods detect light and dark, and they detect movement. We have many more rods than we have cones, but these animals have many more rods than we have, and so they have good vision at night. This combination of rods in the retina and the tapetum lucidum is called night vision. You do not have night vision to any significant degree. They have it 6 times greater than you. So if you're traveling in Kenya and you want to go for a walk at 10 o'clock at night, I would suggest you not do that. And the reason is these animals see you long before you see them. Let's move on to the whiskers. The scientific name are vibrissae. The whiskers are usually located above the upper lip in the form of a grid. Sometimes they're located below the lower lip. They can also come out of the cheek. They can come out of the eyebrow. They can even, on a dog, come out of the front limb above the paw. They are extremely sensitive to touch. At the base of each whisker, there's 2 to 4 nerves beginning. When the whisker is touched, the nerves are activated and bring sensory information to the sensory side of the brain. They come in different sizes. They might be small, they might be large. For a tiger and a lion, they usually extend out to the width of the shoulder. When these animals are walking in the dark, in the very extreme dark, they navigate by their whiskers. That tells them where they can go and where they cannot go. The other wonderful thing about the whiskers is they work underwater for otters, for seals, for walruses. These, when they are touched underwater, fire off those same nerves. So when a river otter is in dark water, if a fish goes by and touches his whiskers, it enables the otter to catch the fish as its prey. So they are, in my opinion, whiskers are understated. This is just a picture I promised you of a carnivora with the keel of bone called the sagittal crescent. This is a picture of the teeth. Their teeth are specialized in 2 ways. Over on your right is a frontal view of the bear, or, yeah, I think that's a bear. The frontal view showing the canine teeth as very elongated. You have 4 canine, 2 above, 2 below, but theirs are very elongated. So when they are chasing an animal and they get very close, they open their mouth and they fixate that prey with those long teeth. They can attack the back of the neck and break the neck, causing the animal to fall, or they can attack from the front and close off the airway, causing the animal to fall by passing out. At that point, they start to use the teeth on your left. Those are molars, and they are premolars, and they're very different than yours. Your molar teeth are blocks of bone. They're cubes. But these are more, in my opinion, like a mountain. They rise sharply to a midline ridge, which is very sharp. That ridge lines up with the ridge of the next tooth, and so on down the line. That is where this powerful force of 1,000 pounds per square inch is applied along those ridges. It allows the animal, the predator, to tear the flesh of the animal prey. There's even a better story about this in the hyena, which Cindy will refer to a little later. So those are the carnassial teeth. Carnassial means flesh tearing or shearing. These are 2 examples. On the left is an animal called a bitcheron, an animal I've never seen, and on the right is an animal called a fossa. These, as you can imagine, are carnivora. Their eyes and their orbits are very far forward. It also is a nice picture of their whiskers. Let's move on to the tongue. Your tongue has many bumps on it called papillae, but your tongue is very smooth. If you have a cat lick your hand, you know how rough that is. That's because their papillae have a hard surface on it. We call that cornified. They take advantage of that, both domestic cats and the big cats. When they're finishing their meal out in the wilderness, and they've almost finished, there's still a little bone, muscle left on the bone. They use that tongue like a rasp, and they pull the muscle right off the bone. Again, high efficiency. Let me back up. I'd now like to move on to the paws. The paws are in some ways like yours. I don't want to fall on my face. This is actually the hand, the front hand of a bear. And your hand, from here, from the knuckle to the wrist, has 4 long bones, which are these 4. And then the knuckle And beyond the knuckle are your digits. And we have 4 here if you're not talking about the thumb. And so they, at the junction, is where they are touching the ground, the carnivora. And as Cindy told you, that's called digitigrade. D-I-G-I-T-I-G-R-A-T-E. Most of the carnivora are digitigrade, but there are exceptions. One is the bears. All of the bears are plantigrade, like you are. Meaning that the front of the foot is contacting the ground and the back of the foot is also. The entire foot is making contact. So those are an exception for you. The raccoon, his genus is also an exception. They are plantigrade, and I will show you a picture. Now I'd like to go on to the claws. Their claws are the same material, the same protein as your nails. Our nails are flat and they're horizontal in relation to our fingers. The claws are also flat if you look at them like this, but they are more vertical. When a claw moves forward, it is rounded and it comes to a point. That's the definition of a claw. Some animals, most carnivora, have a sheath on the back of each digit. And in that sheath, the claw can be withdrawn because there are muscles attached to the claw. And that is extremely efficient. When a lion and a tiger are running greater than 30 miles per hour, they don't want their claws to get in the way. But when they get close to the prey, they then bring those claws forward. That's called protracted. They protract their nails and they fixate on the animal when they lunge, just like they fixate on the animal with their canine teeth. There's an exception, and the exception is the bear, and this happens to be a bear. His claws are always protracted. They're out, and they cannot be pulled in. And if you look at our sun bears, you will be very appreciative of claws. So, I've taken you through the story, I've taken you through the theme, and I hope you will agree with me that these animals are extremely efficient as predators. I'd like to show you a few refinements within the order. On the upper left is a large cat, and he is springing forward toward his prey. He does that with very large muscles in his hind limbs. He can jump forward 20 feet. On the right is a hyena. If you notice, his back is sloped. I am told, I don't have proof, but I am told that that allows for longer limbs, and it allows them to run a very long distance, like 30 miles. Now, a lion and a tiger cannot do that. They are sprinters. They cannot run long distance, but it is somehow related to the long front limbs. This is just showing river otters, how sociable they are. The lower right is showing you a raccoon, and his hand, if you notice, has no hair on it. That's indicating he's using the entire front foot, and that's because he is plantigrade.
Aren't those sea otters?
Yeah.
Yeah. Okay, now I have not paid a lot of attention to their hearing and their olfaction. They have wonderful hearing and wonderful olfaction, but I don't have time to devote to that. I did devote a lot of time to their vision. These are more refinements of the order. On the lower left are the meerkats. If you notice, there's dark fur around their eyes. They live in the desert where it's extremely bright. It is theorized that this darkness helps to decrease the glare in their vision. Conversely, in the right lower corner is a tiger, and the tiger lives in jungles and in tall grass. So he wants his vision enhanced. It is theorized that the stripe on the bottom, just at the bottom of the eye, reflects more light into the eye, enhancing their vision. This picture up above is a cat, and it's a photograph of a cat, a flash photograph, And you have perhaps noticed the color coming back at you in a photograph. In the cat and the dog, the reflection is green. In a horse, the reflection is blue. In the human, for a very different reason, the reflex is red. The colors green and blue are because of the tapetum. The crystals in the tapetum reflect that beautiful color back. This is a final slide of this section of a painted dog, and it is just to show you another refinement within the order. These ears are large and they have muscular control, so that if the animal is facing me, but he hears an object to his left, those ears can pivot a little due to musculature. We don't have that. Well, I guess we do have that capability if you train yourself to wiggle your ear. I can't do that. Cindy, I'm sure, can do it. Okay, your turn.
Everybody hear me? Can you hear me? Okay. Yeah. So some of the key things to know about carnivores in addition is that the largest of the carnivores typically are apex predators. Apex means the top of the food chain. So they are the highest of the carnivores in their realm, and they are very important in the ecosystem because they modulate the balance of the entire ecosystem. They're sort of the kings and queens, if you will, of the ecosystem. And as apex predators, they make sure that prey balance is right. So, in many conservation issues, you may find that the apex predators, when they're removed, the balance gets all out of whack in an ecosystem. And that's because that apex predator has such an important role. Oftentimes, the concept of apex predator is also interchanged with the concept of keystone species. But these are in fact two different things to understand separately. So the apex predator is the top predator balancing the ecosystem for predation. However, a keystone species in an ecosystem does not have to be the apex predator. It can be some other organism within the environment. For example, a beaver. A beaver is a keystone species. It's not a carnivore, but it's crucial in the ecosystem because what it does is create habitat for myriad other species. When beavers build dams, they are actually creating habitat that all the other species depend upon. So they're not a carnivore, but they're a keystone species. So really important to understand those two concepts. But typically, carnivores are apex predators and/or keystone species in the ecosystem. The small carnivores in the order Carnivora can serve multiple functions within the ecosystem. And a good example of that is the coati. The coati may prey on small animals, but it may also spread seed through its diet and help to regenerate the ecosystem in which they live. So multiple functions are possible. In general, carnivores are extremely intelligent species, and much of their behavior is learned, not instinctive only. So the carnivores, as they're maturing, have to do a whole lot of play, a lot of practice, particularly if they're a predator, but in general, for whatever a carnivore's lifestyle is. They learn by practicing. They often will learn by socializing with their peers if it's a species that has siblings when it's born. And they learn and they remember. And that's incredibly important. If you think about a predator who's got to remember, gee, where do the elk like to hang out in the wintertime versus where the elk might be in the summertime. Also, in general, and again, I'm speaking in generalities, we're not supposed to do that, but it's important for kind of getting the framework in your head. Males of Carnivora tend to be larger than females. So that's another key characteristic. Carnivore reproduction is fascinating. So the males of Carnivora have what is called a baculum. And humans do not have a baculum, but what a baculum is actually a penis bone, such that this is not a femur. This is actually a walrus baculum. Can you all see this? Kind of like a baseball bat. So The penis is incredibly strong when erect, and that's important because in carnivores, oftentimes the biology is so intricately woven with access to a mate and with the resources in an ecosystem. So for carnivores, ovulation in the female, the laying of the egg within the female's body, is often induced by the reproductive act.